Welcome to solverfy.
(6.43). So we have this is part of a series of problems involving this table to do with the periods or to do with the orbits of Jupiter's moons, or the 4 largest moons of Jupiter. And so for this problem in this series, we want to use the mean distance from Jupiter value for Io to find the other mean distances using Kepler's third law, and then we want to compare our results with what we get in the table. So we'll use the period and mean distance from Jupiter of Io. So we'll call these T2 and R2. And so we're going to want to find R1 for Europa, Ganymede, and Callisto. So basically, we have one problem to solve here, so let's go ahead and solve that. So we have Kepler's third law. With the period and average distance, the period squared being proportional to the average distance cubed. And this means that R1, which is what we're calling these other things, or the distance for Europa, Ganymede, and Callisto, is equal to R2 times the ratio of the two periods to the 2/3 So for Europa, we put in its period is 3.55 into this, and we get 671 times 10 to the third kilometers, which agrees with the table. So far, so good. For Ganymede, we have that its period is 7.16 days, so we put that in here. And we find that its average distance from Jupiter must be 1,070 times 10 to the third kilometers. And this also agrees with what the table says. So the table, so far at least, is consistent with itself and Kepler's third law. And presumably being compiled from actual data from observing these things, this means that Kepler's third law actually works, as you would hope. So for Callisto, then, its period is 16.7 days. And so we end up with an average distance of 1,880 times 10 to the third kilometers. And this is a wrong in the fourth digit here, and that probably has more to do with the number of digits of precision we have for the orbital radius and period of Io than it does, and the Callisto for the period, than it does to do with Kepler's law, not Kepler's third law not working. So this is still quite good, and probably if you had better numbers for these, you would get an exact agreement.